Hello everyone. We'll start our week one question review section. In this section, I will provide you with an overview of the possible questions you're going to see in your quizzes and in your exams. So the questions will not be identical, but the question in this review slides will be very similar to those questions you're going to see. Okay. And just note, the quizzes and exam questions will be multiple choices or true or false questions. But in this question review slides, I'm directly giving out the answer for just simplicity. Let's first see the first question. The first question is saying a sample of plastic with a mass of 10 grams was burned. The ashes weighed 6.8 grams. What happened to the rest of the plastic? If you still remember what we have learned from our lecture section, if there's only one rule you should remember after this course, that rule should be, yes, the law of conservation of mass, which means in the chemical reaction, the mass of the reactant will be identical to the mass of the final product generated. So in this question, it is saying the mass of 10 grams of the plastic was burned, which means we have 10 grams of the plastic as a reactant initially. And then after the chemical reaction, we have 6.8 grams of the ash as one product. So what happened to the rest of the plastic? The rest of the mass must be converted to another type of product, and the product should be the gaseous because it is there's no weight. That's why the correct answer for this first question should be it turns into the gas and released to the environment. Okay, now let's see the second question. What is the difference between an observation and a hypothesis? Um, we know like the observation is something we see or something we touch or something we smell or something we hear. Okay, a hypothesis is something we are trying to explain an observation. Now let's see. Let's first see the first choice. When I switch the knob, the bulb turns on and emits light. This is definitely an observation because this is just what we observed of the bulb lighting on, right? Second one, lava from the volcano is hot. This one is also an observation because hot is something not it's something we could not see, but it is something we can feel. So based on the concept of the definition of observation in the chemistry, the feeling is also a type of observation. Okay. The third one, dog can run because they have eyes. So this one, it gave us a statement, which is the dog can run. And it gave us an explanation because they have eyes. Although this explanation, by our common sense, it is wrong, but it is still a hypothesis. Just keep this in mind. A hypothesis can be a correct hypothesis or a wrong hypothesis, but they all the hypothesis. Okay. The last one, frog have four legs. This is something we observed, so this is an observation. Now let's see the third question. Third question is asking how many significant figures in the number of 25,000.000. 25,000.000. Because we know there's a one decimal point here. If there's a decimal point and the zero should be counted as the significant figures. That's why in total there are 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 significant figures. Okay, but let's say if I change the question into how many significant figures are there in this huge number without the decimal point, then this zeros should not be counted. This trailing zero should not be counted. So in this case, there should be only 2 significant figures. Okay, so we know for this question, the correct answer is 8. Okay, next question. It is asking you in the number of 27.65, which digit is estimated? We know from what we learned for a measured figure, the last digit must be an estimated digit. So in this case, the correct answer should be 5. Next question. If 8.6699 is rounded to 2, 3, and 4 significant figures, what will be the number? Let's check this figure. 6.6699. Okay. This number have in total 5 significant figures. But if I want it rounded into 2 significant figures, which means I will only keep 8 and 6 because this 6 is larger than 5, so I need to add up 1 at here. So which means if I round it to 2 significant figures, the number I get will be 8.7. If I round it into 3 significant figures, which means I need to add 1 here because I have a 9 here. So the answer should be 8.67. Last one, if I want to round it into 4 significant figures, which means I should add 1 here. The correct answer should be 8.670. Okay, these are the 3 answers for this question. Next question. This question is asking you to calculate 3.215 times 13.2 divided by 0.218. We have 3.215 multiply 13.2 divided by 0.218. So first we want to calculate 3.215 multiplied by 13.2. So what will be the result? Let me do a calculation. 3.215 multiplied by 13.2. I got 42.438. But remember, for the multiplication, the answer should be bounded by the number with the least significant figures. So which means it should bound it by this number. So although this is our intermediate result, we should count it only 3 significant figures. So we should only count this part. But since our calculation is not done yet, we don't want to do any rounding during our calculation. Okay, but just keep in mind we only have 3 significant figures. Okay. And now I'm calculating the division. Okay. I'm using this intermediate result divided by 0.218, which will give me the result of 194.6697. Okay, but again, our final result should be bounded with a number with the least number significant. So I know for the intermediate result, I have 3 significant figures. And for this 0.218, it also have 3 significant figures, which means my final result should also have only 3 significant figures, which means I need to round this very large number into the number with only 3 significant figures. So my final result should be 195 because I have a 6 here. I need to add 1 to this 4. Okay, this is our final result, 195. Next question. Next question. It is a question about the plus and minus. So we have a number 17.103 plus 2.03 multiplied by 1.02521. So first we have a parenthesis, which means we need to calculate the content in this parenthesis. So for this parenthesis, 17.103 plus 2.03, we got the answer of 19.133. But since this is a plus operation, this is a plus operation, so remember the result of the plus operation should be bounded by the number with the least decimal places, right? So this have three decimal places, and this have only two decimal places, which means for this intermediate result, it should only have two decimal, which means the result should be 19.133, 19.13. But since this is our intermediate result, we don't want to do the rounding during the calculation. So we still want to use 19.133 for the following calculations, okay? And then we will use 19.133 times 1.02521. Now, let me calculate what is the result. The result is 19.6153. Okay. Now we are dealing with the multiplication operations. So for this 19.133, we should count as only have four significant figures because we only count this part. And for 1.02521, there are in total six significant figures. Here we have four and here we have six. As we mentioned, for the multiplication operation, the final result should be bounded by the number with the least number of significant figures. So which means our final result should be rounded into a number with only four significant figures, which means our final result should be 19.62. So 19.62 is our final result. Okay, so much for the calculation part. Now let's see the next question. What is the base uh, uh, international standard unit for the length, mass, temperature, and the time? This is just something you need to keep in mind. So for the length is a meter, for the mass is a kilometer, for the temperature is a Kelvin, and for the time is a second. Okay. Next question. A solid from the matter in which there's a long range of repeating order is called. Remember, so for the matter, especially for the solid, if it has a long range of the repeating order, which means the orders are just repeating within a repeating pattern, this can be observed, can be viewed as a pattern because it's just repeating and repeating. So this is called the crystalline solid, okay, or crystalline state. In another case, if the solid are not have the repeating pattern, they are just randomly packed without any repeating patterns. This is called the amorphous states. So in this case, it is asking us the long range repeating order. So that is the crystalline structure. Okay. Next question. Which is not example of the physical properties? Let's see. First, the water can form hydrogen and oxygen under the electrolysis. Electrolysis. Second one, liquid water can turn into steam. The third one, ice is brittle. We know just the first one, it describe like it is a chemical reaction because water decomposed into hydrogen and oxygen. It is no longer water anymore. So definitely the first choice will be a chemical property. Second one, liquid water can turn into steam, as we mentioned in our lecture. This is just the phase change. So the phase change can be regarded just as a chemical property. The third one, ice is brittle, because even though ice is brittle and we can break it into the small, tiny ice, the ice is still ice. Nothing changed. So the third one is also a physical property. So that is why the first choice will be the correct answer. Water can form H and O under like it, the next one. Next one. The question is: when methane is born with oxygen, the products are carbon dioxide and water. If you produce 9 grams of water and 11 grams of carbon dioxide from the 16 grams of oxygen, how many grams of methane were needed in this reaction? First, let's based on the statement, let's try to write down the chemical equation. Okay, it's saying methane can burn with oxygen. Okay, it reacts with oxygen to generate a carbon dioxide and can generate water. So as we mentioned, during the chemical reaction, the mass will be conserved, which means the mass of the reactant will be the same as the mass of the product. And that is why, in this case, uh, we have um, 9 grams of water produced, and we have 11 grams of carbon dioxide produced as our product. Okay, and what about the reactant side? The reactant side, we have 16 grams of oxygen. So how many methane should I got? The methane should be the methane should be then 11 plus 9 minus 16, which will give us 4 gram. That is why for this question, 4 gram, it is the answer. Okay, next question. This question is asking us, um, this question is asking us, which of the following item is not a common unit of energy? Okay, for energy, we know like the joule, kilowatts, hour, and calorie are all the units of energy we studied in our chapter 3. That is why the torr is not a common unit for energy. The torr, just for your information, is actually a unit that describes the pressure, especially the pressure of the gas. Okay, so it is a pressure unit. Now let's see next question. What is the value of 335 K on Celsius temperature scale? So this question is asking us to convert the K into the Celsius scale. So how do we do that? By the way, you don't really need to remember any equations for this conversion. So those conversion equations will be provided. The conversion equation to convert Celsius to K or K to Celsius is Celsius equals 273.15. Oh, wait. K equals 273.15 plus C Celsius degree. Okay. So now we are provided with the K, which means the K is 335. So what will be the scale in Celsius? The Celsius then should be 335 minus 273.15, which will be around 62 degree if we just do a rounding. Okay. Okay. So this is just a brief summary, a brief question review summary of the example questions you're gonna see for chapter one, from chapter one to chapter three. I hope it is helpful for you guys to get fully prepared. And also, in this, at the last slides, I provided you with some like the classification I wrote down, like a classification chart. This will cover some basic classifications, not only for from chapter one to chapter three, but also we'll cover something we're gonna learn for the next week in chapter four and chapter five. So I hope this can help you to better understand so what is a matter and how we classify the matter based on their state and based on their like the whether it's pure or not. And this chart will also be helpful for you to understand the structure of the atoms because we also try to classify the atoms into like into their different component. For example, the electrons and nucleus, and can also help you to understand better about the periodic table, which we're gonna learn for next week. Okay, that's so much for this section, and I hope this is helpful for you to just study the basic concept we have learned this week. Thank you so much for your attention. Bye bye.